Hello, in this video, I'm going to discuss about the goodness of fit test. So the goodness of fit test is a type of hypothesis test and it is used to test if sample data fit a distribution from a certain population. Uh, for example, a population with a normal distribution or one with a binomial distribution. So in other words, it basically tell you if your sample data represent the data you would expect to find in the actual population. So you have a variety of goodness of fit test, and chi-square one sample goodness of fit test is one such test that can be used to test the goodness of fit of a sample to its population. So chi-square goodness of fit test determines how well theoretical distribution such as normal, binomial or Bayesian fits the empirical distribution. So it can be used, I mean, whether it is normal, binomial or Bayesian, you can use basically the chi-square test. Given that you have only, you are going to test goodness of fit, test for a single sample. So you can, in that case, you can go by chi-square goodness of fit test. So it is a non-parametric test. That means it is not based on a specific distributional assumption. It doesn't assume that the population follows a specific distribution. So in that case, you can use it to test uh, whatever may be the distribution of your assumed distribution of your population. You can basically test your sample distribution, uh, represent or represent the population distribution. So it basically compare the observed sample distribution with the expected probability distribution. Or we can also say it is used to find out how the observed value of a given phenomena is significantly different from the expected value. I can give an example here. You know that when you flip a coin, right, or uh, over a large number of times, what you find, uh, you find that the theory says that you should get 50 percentage of heads and 50 percentage of tails. That means the probability of getting one head is 1 by 2. So that is this distribution is your theoretical distribution, right? So the theoretical distribution says when you flip a coin a large number of times, you should get 50 percentage of head and 50 percentage of tails. Now, okay. Now you started flipping a coin. You flipped it over, I can say 50 times. Then you found that you got 27 heads and 23 tails. So it doesn't actually looks like, following the theoretical distribution, right? It doesn't actually fit to the theoretical distribution, but you don't know actually at this point of time whether it is significantly different from the distribution of the population. Okay, so that is the case where you can use a chi-square test, and it will tell you whether whether this the sample distribution, whether it is significantly different from the population distribution or not. So that is the case. Those are the cases where you can actually use this chi-square test. So now let's see what are the procedure for conducting a chi-square goodness of fit test. So the processes are similar to the hypothesis test, where the first step is, of course, setting up the null and alternative hypothesis. So the difference here is, here the null hypothesis is all about the population distribution and sample distribution, right? So here uh, your null hypothesis can be like this: there is no significant difference between the population distribution and sample distribution, or you can also say there is no significant difference between the observed and the expected value. So here the expected value represent the assumed distribution or the population distribution, and the observed distribution is nothing but the sample distribution. Okay, and your alternative hypothesis can be specified like this: there is a significant difference between the observed and expected value. So this is how you supposed to specify the null and alternative hypothesis under chi-square goodness of test. And the next step is, of course, computing the value of chi-square goodness of fit test. So you can use this, this formula, where the chi-square test statistics is specified as sum of observed minus expected value whole square divided by expected value. Okay, where O stand for, of course, the observed value, that is nothing but the sample data. Okay, and your the E here represent the expected values, that is nothing but the theory, right? The assumed distribution or the population distribution. And yeah, so that is it. And the last step is, of course, decision making. So of course, before you go to decision making, you should find out the critical value. So like the chi-square test that we have done when we were doing, the hypothesis test for variance, single sample variance. You might remember, right? We have uh, done this exercise to find out the critical value, right there. So like that, here also we need the help of the degrees of freedom. You should know what is the degrees of freedom and at what is the level of significance, right? So these are the two information that you need to, I mean that you need to find out the critical value for this goodness of fit test. So you go to the chi-square distribution table. So you know it is a right skewed distribution, right? So you have only positive numbers, and here so if you go by a particular degrees of freedom and level of significance, so you will get a critical value from the chi-square table, and you can compare it with the test statistics. Okay, that was one way you can make a decision about whether to reject or accept the null hypothesis, right? So if the critical value, sorry, if the test statistics is greater than the critical value, then you basically reject the null hypothesis, right? The similar way, if your probability, the estimated probability is less than the level of significance, that was another way you can make decision about acceptance or rejection of the null hypothesis, right? So if in this way of making decision, if your the estimated probability is less than the level of significance, you basically reject the null hypothesis. Okay, so this is all about the chi-square goodness of fit test. I will come up with a video on the an example in Excel on this test. So bye.